Hi everybody, this is Mr. Short. Today we're going to talk about Lewis structures. I want you to know that Lewis structures are a simplified way that we can represent valence electrons for a substance, and it relates to an element's position on the periodic table. Before we get to drawing Lewis structures though, I want us to take a look at some electron configurations and figure out how valence electrons are represented in the electron configuration, how that relates to an element's Bohr atomic model and the number of valence electrons we see there, and then ultimately build up to Lewis structures. So you can see to begin with, I've got lithium, I've got its complete electron configuration right here. Lithium is a main group 1 element and it's got 3 total protons and therefore 3 total electrons. Here's its electron configuration. If we take that and we turn it into a Bohr atomic model, on the first energy level, we would have 2 electron dots, and then on the second energy level, we would have 1 electron dot. Now, I also want you to notice that lithium is in main group 1 of the periodic table, and it's got 1 valence electron right here. Keep that in mind. Also, we've got fluorine. Fluorine is element number 9. And I've got its complete electron configuration right there. Let's take this information and turn this into a Bohr atomic model. So first energy level, 2 electron dots. Second energy level, 2 electron dots. Still on the second energy level, another 5 electron dots. So another 1, 2, 3, 4, 5. So what we see here is that fluorine has these 2 plus these 5. That's a total of 7 valence electrons. And fluorine is also in main group 7. So I'm going to go like this. Fluorine is in main group 7, whereas lithium, if this cooperates, lithium is in main group 1. Now remember, the element's main group number tells you the number of valence electrons for that substance. So I'm going to change this to red right over here, and I'll put this little note. So it says, using your periodic table, determine the number of valence electrons for that element. Well, the saying is 1, 2, skip a few, 3, 4, 5, 6, 7, 8 from main groups. And the main group number tells you the number of valence electrons. So we've got main group 1. Here's main group 2. We skip that central region. It would be the central depressed region that's called the D block from scandium over to zinc. So this is main group 3, 4, 5, 6, 7, 8. And that main group number, 1 through 8, tells us the number of valence electrons. Well, we already saw, for example, that lithium has 1 valence electron. There it is, and it's in main group 1. We also saw that fluorine has these 2 plus these 5. That's 7 valence electrons, 7 electrons in the outermost energy level, and it's in main group 7. So that should confirm for us that the main group number tells us the number of valence electrons. So now let's build up to Lewis structures. When you're drawing a Lewis structure, you're only representing the valence electrons, and you always follow this pattern. For xenon, for example, and xenon would be right down here. I'm going to change the color, about blue. Xenon would be down here. It's a main group 8 substance, main group 8 noble gas. We would follow this pattern and listen to the words single, 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 single before double, 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 double. Okay, so we always go singles first, single, 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 single before double, 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 double. You can see the 8 valence electrons in xenon. Xenon is in main group 8, so it has 8 valence electrons. Okay, if we do 3 more examples here, barium is right down here. It's actually 2 spots below calcium. Indium is a main group 3 element, and it's 2 spots below aluminum, so I'll put indium right there. And selenium is a main group 6 substance. Selenium goes down here. For barium, which is main group 2, it would get 2 electron dots, so it would go single, single. Indium is in main group 3, so it would get 3 electron dots. It would go single, single, single. Selenium is in main group 6, so it has 6 valence electron. Remember, singles first, so single, 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 single before double, double. So importantly, you can see that selenium, which is in main group 6, 6 valence electrons, it has 2 pairs of electrons plus 2 so-called unpaired electrons. So what I want you guys to do is to follow this pattern that we reviewed right up here. Remember, it's singles first, and fill in the Lewis dot structures for all of these substances that are given here on this abbreviated periodic table. Okay, that's your assignment. All right, thanks a lot, guys. Talk to you soon.